Hello students, in this video we will be seeing about the realization of 4:1 multiplexer. In the last video we saw about the realization of 2:1 multiplexer using pass transistor and transmission gate logic. In this video we are going to use the same pass transistor and transmission gate for the implementation of 4:1 multiplexer. So we know what is a pass transistor. What is the pass transistor? It is nothing but an N MOSFET with a control signal. So if that particular voltage that is given to the gate is on, whatever value is there on the left side will be passed to the right side, right? So now we are going to implement for a 4:1 multiplexer. So 4:1, where 4 is nothing but your inputs and 1 is your output. So how many number of select line must be there? If 4 is the input, what is 4? 2 power 2. So what is 2 power 2? The power is 2. So 2 number of select line must be there. You all know this already. So now 4 inputs are there, namely A, B, C and D. And the 2 select lines I am naming it as S0 and S1. And Y is the output. What is it? Y is the output. Now, S0 and S1 and Y is your output. What are the various combinations I can make? 0, 0, 0, 1, 1, 0 and 1, 1. So for these 4 different combinations, I'm going to take my output Y. So if my S0 and S1 both are 0, what data must be passed? What is there on 0, 0 line? A data. So A will be at the output. Next, 0, 1. What is there? B. And next, what is there towards 1, 0? C. What is there towards 1, 1? D. So if my select line data is 0 and 0, Y will be equal to A. If it is 0 and 1, it will be equal to B. If it is 1, 0, my output will be C. And if it is 1 and 1, my output will be D. Now, how can I write the expression? See here in this unit, whatever the question is, first you try to make a truth table. After writing the truth table, we can easily write the Boolean expression. Once you know the Boolean expression, either you can implement the particular expression using static CMOS logic or dynamic CMOS logic or pseudo NMOS logic or pass transistor logic or transmission gate logic, whichever is easier. Right? If suppose you are finding it so difficult, you can easily implement that particular logic using static CMOS logic. You just blindly you can put a pull down network, pull up network, connect this inputs, and you will easily get a static CMOS logic. But the number of transistor that you are going to use will be more. That is what we are seeing other versions as well. You can implement the same expression y is equal to what is there over here using static logic also. But instead, I'm just using pass transistor just to show how easier the pass transistor is. So now see, y is equal to S0 bar, S1 bar into A. How? It is 0, 0. For 0, 0 combination, my output y is equal to A. So just S0 bar, S1 bar into A. Plus, what is the next combination? S0 bar into S1 because it is 0 and 1. So for 0, in the place of 0, I am giving us S0 bar, and in the place of 1, I am giving S1 into B. Plus, what is the next combination? Of course, 1, 0. For 1, 0 combination, what I will be giving? Which is S0 into S1 bar into C. And for the last combination, both are 1. So just S0 into S1 into D. So my expression is given. Now with this expression, I'm going to implement a 4:1 multiplexer where there are 4 inputs, 2 select lines and 1 output. Now, what is this? Yes, first we shall take the first term. What is it? S0 bar, S1 bar into A. What data has to be passed? A. So keep A in the left side. Because it is an input, you can directly keep A over here. When A is given, What are the two other terms? S0 bar and S1 bar. Because I'm using a pass transistor, we need a control signal. What control signal I'm giving? S0 bar and S1 bar. If S0 bar and S1 bar are there, what data will be passed? A will be passed in the output. Right? Now see, maybe you may find it a little bit confusing. We shall see for the next term very carefully. What is it? S0 bar, S1 into B. What is the data? Data is B. Now for B, what are the two more letters which is there? S0 bar and S1. Connect to N MOSFETs or two pass transistor in series. So you'll be getting B into S0 bar into S1 the output. Now again I will be repeating for the data C. What is the C? What are the two more letters are there? S0 into S1 bar. So I can write here, I have just wrote as S1 bar for your understanding purpose, because both I can write S0 first and S1 bar second, or I can write S1 bar and S0. Both are the same because we are just adding all these three. So just S1 bar into S0 into C will give you the third term. What is the fourth term? S0 into S1. So I am giving the control signals directly as S0 into S1 into D. That is going to give you the output Y. So Y is equal to S0 bar S1 bar into A plus S0 bar S1 into B plus S1 bar S0 into C plus S0 S1 into D. So this is the 4:1 multiplexer using pass transistor logic. I guess you understood this concept. It is so easier. And next, we shall see about the transmission gate logic. So now we are going to implement the 4:1 multiplexer using transmission gate. Don't be panic with this circuit. This is so easier. What I have drawn? A transmission gate. I can draw the transmission gate in this manner also. Right? Now, we usually want S0, S0 bar, S1, S1 bar. So what I have drawn, a static inverter has been drawn here. I have taken S0 over here and S0 bar on the opposite side of the inverter. Again, I have used another inverter for the select line S1 and S1 bar, S1 and S1 bar. I have drawn two lines so that I can take wherever I want S0 and wherever I want S0 bar. In the same way, wherever I want S1 and S1 bar. Now, what was the 4:1 multiplexer? When my data A will be selected, my A will be selected when S0 and S1 both are made equal to 0. For the combination, see on the bottom, I have written S0 and S1 when both are 0, my Y will be equal to A. Clear? Now see how this is going to work for the particular combination 0 and 0. What data I have to pass? A. So A is written over here, and now on the left, in the top left, I have drawn A. Now A is the data that is to be passed, and that will be passed in the output Y when both S0 and S1 are 0. So what is this? I can directly take S0 line. I can draw from S0 as well as S1. Don't think that 0 means S0 bar. No, I'm just directly saying my S0 is 0 and S1 is 0. I will be feeding my 0 and 0 on S0 and S1 line, not on S0 bar and S1 bar. Right? Don't confuse 0 means it is bar. No. So 0 is being fed on directly on S0 line, and again one more 0 is fed on the select line 1. So 0 and 0 is being given, right? And then if 0 and 0 is given, what is the opposite bottom control line? It is S0 bar. We know in transmission gate, if one is positive, one more clock signal or one more enable signal will be negative. So one top is S0 and the bottom is S0 bar. So if it is 0, again at the bottom will be 1. You check whether the first transmission gate is going to, my first transmission gate is going to turn on. See, I'm feeding 0. 0 is going to turn on your PMOS and 1 is again going to turn on your NMOS. So what will happen? The first transmission gate is on. As transmission gate 1 is on, A will be passed in the output. Right? Now, A is passing. Again, I want to check for the select line. S1 also. What is the select line value? S1. So 0. S1 is equal to 0. This 0 is passed to the PMOSFET. 0 to a PMOSFET will turn on the transmission gate. Again, 1 which is there on your S1 bar. So 1 will turn on your NMOSFET. So what is going to happen? The data A will again pass in the output and Y will be equal to A. We shall see for the second combination. What is the second combination? S0 is equal to 0 and my S1 is equal to 1. So now I am passing S0 is equal to 0, right? And my S1 is equal to 1. To check, I have written S0 is equal to 0. And again, I am not taking S1 bar. I want only S1. S1 is equal to 1. Why I have not drawn in this fashion? If I draw a line 1 to my PMOSFET, that PMOSFET will turn off. I want to pass the data. So I want to make sure my transmission gate are on. So how can I make the transmission gate on? By giving 0 to a PMOSFET and by giving 1 to an NMOSFET. So what is happening? My D data has been passed and output is equal to S0 bar S1 into B. And again, this is for the combination 0 and 1. Check for the C, it is 1 and 0. So 1, so I have taken my C has to pass. When I give 1, my N MOSFET will turn on. Again 0 to a P MOSFET will turn on your C. So my C is going to pass and this C is going to again another transmission gate where I need to turn on the particular transmission gate. To turn on the particular transmission gate, I have given my S1 is equal to 0 and my S1 bar is equal to 1. So again that particular transmission gate will turn on and thereby my output is equal to S0 S1 bar into C. Again, it is so simple. The last one, which is 1 and 1 combination. So both S0 and S1 are connected to 1 and these ones will turn on your N MOSFETs, and whereas the 0 on the S0 bar and S1 line will again turn on your P MOSFET. So both transmission gates are on. Directly D will be at the output. Right? Is it clear? Just go through this diagram again. You'll be understanding this logic in an easier manner. It is nothing but once you forget the logic, when your N MOSFET and P MOSFET is going to turn on and off, it's highly impossible. I'm repeating it again. So kindly make sure you know the working principle of your N MOSFET and P MOSFET to score well. So in your next video, we shall see about the sudden combinational logic. Thank you.